no longer going to have quizzes. You are going to get grades for doing things like coloring. For real.
Wait,
For real.
is that fine to be on the camera?
Huh?
Is that fine to be like in the video?
Yeah, let's shut that part off. All right, things that you need to know. 3-day, day 4 that you did last night, please put them in the middle of the table. I graded the ones that you turned in yesterday. Friends that I had conversations with are turning in whatever they were supposed to turn in right now. Right now. Celeste?
Yes.
Stuff from yesterday? Put it in the middle of the table. Alright, here comes the 3-day, day 2. We've got Ailey, we've got Maida, we've got Carmen, Steven, Andrew, Giselle. Alright, Lewis. Alright, Ailey. And if you guys would take out the practice test from yesterday, Ailey, Andrew, no, he's Ducky. No, Andrew. Okay, so turn it back into me and I'll look at it again. Just make a note that that's where I need to look, okay? Steven, here you go. Carmen, Palamon, Myra, David, Celeste. Okay, so, all right. That takes care of that business. Homework tonight, 3-day, day 5. We know. Lewis and Celeste, turn in your stuff. Good. A reminder for everybody in the world, whether you're here in the room, Stephen, we're filming now, right?
Yeah. Well,
Okay. Huh?
It's been filmed for.
That's fine. Charge your calculator, charge your calculator, charge your calculator, charge your calculator. Okay, charge the calculator. There are only 2 charging stations right now. You want to fill them before the other friends get here. You know, the other letters of the alphabet. The A-B friends. Okay, there's that. Tuesday is the exam. Tuesday, you are taking the exam in here. You're going to be in this room Tuesday morning. Do not go to base camp. Do not go to morning meeting. Do not go anywhere except here. Okay? Just want to make sure that we know. Who are the folks in here taking AP French Tuesday afternoon?
Oh,
That doesn't impact any of you all. Sweet. There are 5 Calculus AB students who have the Calc AB exam in the morning and AP French in the afternoon. Yeah, good luck to them. All right. Ms. Panda is like, really? The AP Calc exam and AP French? Yeah, there it is. All right, so I think that takes care of stuff. Polymont, today is Thursday. There are 7th graders counting on you. Today is the last day. Do not let me down on this one. It reflects badly on both of us. All right, thank you. All right, so there were 4 questions that I want us to work on before we hit the station rotation, which is going to lead to a blitz. And here's what I want to say about the blitz. Don't panic. Do the best you can. Myra, do you have a question? Yes. All right, here we go. So, question number 11. Raise your hand if you got it right. Oh, that's nobody. No one in the room got the question right. How many of you all picked B? 1, 2, 3, 4, 5, 6, 7. Me too.
Oh, I don't feel bad anymore.
I picked B. We all picked B. It ain't B. You picked A because I don't even know. This answer isn't B. Now, here's what I think happened. Everybody said, okay, you want the derivative at -1. Oh, I should take the derivative over here. F prime is -2x. F prime of -1 is -2 times -1, which is +2. Everybody good with that? And absolutely wrong. Why? We all just took a derivative. We can take derivatives all the time, right? All the time? Why on earth would they give you a piecewise function and ask you to find the derivative? Is there anything special we should maybe be thinking about? How about the fact that in order to take a derivative, you have to first know that the function is continuous. If the function isn't continuous, it can't have a derivative. And so let's check continuity real quick. So the question has to be continuous at x equals 1. If I take the limit as x approaches 1 from the left, right, this is the multiple choice, let's be messy. Limit as x approaches 1 from the left. Oh, negative 1 from the left, negative 1 from the left. Is that 2 times negative 1 plus 5, 3. Limit as x approaches negative 1 from the right of this function, negative of negative 1 squared is negative 1 plus 6 is 5. Conclusion? Limit from the left, limit from the right not equal to each other, so the conclusion? Not continuous. And if the function isn't continuous at negative 1, it can't have a derivative at negative 1. Totally mean, sneaky, rotten hell someday. Hopefully not, because I really want that job too. Alright, is everybody good to number 11? We all made the same mistake for a very good reason. Because we were going way too fast. Alright, 13. Where are my friends that for number 13, you saw this yesterday, a rectangular area is to be enclosed by a wall on one side and fencing on the other, blah, 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 blah. 18 meters of fencing are used. What's the maximum area? Anybody have a little panic attack yesterday when you saw this? Right, maybe you had flashbacks to optimization. Now, so what's going on? We've got a rectangular area, here's my rectangle, is to be enclosed by a wall. Here's my wall. And then fencing. So I need fencing here, I need fencing here, I need fencing here. If 18 meters of fencing are used, what's the maximum area? Well, these two sides, because it's a rectangle, these two have to be the same. There's nothing that says this third side has to be the same. But what I know is that if I add up all those sides, 2x plus y is equal to 18. 2x plus y, but not 2x plus 2y. Why not 2x plus 2y, Lewis?
Because the wall's already there.
Because of the wall. Okay. Back in the day, we called this the constraint. X and y can be anything we want them to be as long as they satisfy this relationship. What is it that we're trying to maximize? I want to maximize area. Well, area is just x times y. This is our optimization equation. This is what I want to take a derivative of. And the problem is I have a function in two variables. I want to take a derivative. I need to get one variable. So this is where we'd use the constraint. If 2x plus y is equal to 18, I hope everybody's okay that this means y equals 18 minus 2x, which means that my area expression is x times 18 minus 2x. If I multiply this out, 18x minus 2x squared. A prime is 18 minus 4x. I took the derivative. Why did I do that? Because I want to set this equal to 0. If I solve it, we're going to get x equals 9 over 2. And 9 over 2 is an answer. Did anybody pick A? Okay, my guess was that A was going to be the distracting answer for friends. A is not the right answer.
You need to find y.
You have to find y? Why do you have to find y?
Because it's asking for the area.
You want to find the actual area. You need to know, what you know right now is how long these sides are. What you need to know is how long this side is as well so that you get the area. Well, if x is 9/2, or maybe you want to think about that as 4.5, what's y? 9/2, 9/2, this guy over here. Or maybe you use this guy over here, it's 18 minus 2 times 9/2, so y is 9. Maximum area
9 times 9.
is 9 times 9/2,
E.
which is going to be E, 81 over 2. Okay. no one has to feel bad about missing these questions. The reason that we're doing the blitz is so that you get this experience and you get feedback the next day so we can figure out where we're going wrong. Here's for the folks that missed this, which is like everybody in the room. Not me on this one though. What happened? I'd love to hear from anybody. How long?
I went down a more numerical standpoint. I just went from 8 times 8 times 2. Like I just did more of a visual.
Oh, so you did like kind of like a plug and chug kind of thing?
Yeah.
Like if it's 8 and 8 and 2,
Yeah. And
if it's 6 and 6 and 6.
yeah, and the highest I
No,
went
no,
up to
no,
was
no,
40.
no, not 666.
The highest I went up to 40, so I thought, oh, it has to be 40.
Ah,
And-
gotcha. And I understand. And you see, they were waiting for you,
Yeah.
right? Because you went whole numbers, right? If you did that, you went whole numbers, and you missed this idea that they could be a fractional value. That's what the calculus is going to get you the precise answer. And knowing how you all feel about optimization, not a surprise. Not a surprise. All right, we've got 2 more relatively quick ones, and then we're going to do a station rotation. Number 16. Number 16, polar. 2 people get this one right. 2 people got this one right. And, oh yeah, I got this one wrong the first time too. I have a really good memory for my mistakes. There aren't that many to remember. So, you know, I've got a list. All right, let R be the region in the first quadrant bounded by the polar curve R equals theta and theta equals k, where k is a constant, k is between 0 and pi over 2. What is the area of R in terms of k? Even if nothing else, I hope, and the weird part with my not getting your test back, I don't know what you did and what you didn't do. But I would hope that as soon as you see this question about area in polar, there's a formula that comes to mind right away. And if it's not coming to mind right away, this is a flashcard opportunity for you. Right, I'd like make a little note if you don't know it, like, flashcard. How many of you guys know the area formula? 1 person? Maybe 2 people? Myra, what's the area, what's the formula that you need here?
1/2
1/2
definite
definite
integral
integral
theta equals something.
from like a starting point, right, to, some people call it alpha and beta, some people A and B, and then
R squared
R squared,
d theta.
R squared d theta. There have been times on the free response where this gets you your first point. Not multiple choice, of course, but free response. So what I need to know in order to solve this problem, what's alpha, what's beta? Where do I start integrating? Where do I finish integrating?
0.
Right? I'm going to start over here. Think about that windshield wiper. I start over here at 0, and I go 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 and I go. Where do I stop? Pi over 2? No. 0 to pi over 2 goes whoop, straight up. It's the line that I think everyone's not understanding. Your angle starts here at theta equals 0. If you're going to pi over 2, that means that you're thinking you're sweeping out this whole place from 0 to pi over 2. Your windshield wiper stops whoop, at the line. It stops at the line. What's the angle there? Not pi over 4. I think you're saying pi over 4 because you're thinking it's halfway. They've not said anything about halfway, but they did tell you what the angle is. Go back and read it one more time. It's k. You don't know what k is, but k is somewhere between 0 and pi over 2. Your angle here is k. So that means your setup is going to be 1/2 the integral from 0 to k. Now I need my radius. Radius is theta. Theta squared d theta. Integral of theta squared with respect to theta is going to be 1/3 theta cubed from 0 to k. So we've got a 1/6 theta cubed from 0 to k. Plug it in, you get a 1/6 of k cubed minus a 1/6 of 0 cubed. I know I went like way fast here, but I'm pretty confident that for all of you guys, like once you get here, this is where things pick up. Everybody okay? All right, one more. One more, and then you guys are gonna hit stations. Where did it go? Oh, 18. Oh, 18. All right, so all we need to do is integrate from 1 to theta, x squared over x cubed plus 2 the whole thing squared. Just take a minute. I need to take attendance real quick. Take a minute, have a conversation with somebody near you. What's your plan? Or what did you try? All right, looks like some folks are trying partial fraction decomposition. Maybe. This would be rough. No one's trying integration by parts. That's a good thing. There's nothing about this problem that makes me think integration by parts. Nothing at all. Some folks have really snapped to the idea that this is an improper integral. You see that infinity, you know things are going to be tricky. But no matter what, you still have to figure out how to integrate. X squared over x cubed plus 2 the whole thing squared. I understand you guys are all reaching for the power tools. Go back to basics. X squared over x cubed plus 2 the whole thing squared. We can integrate this using substitution. All right, what's the u?
You put this.
Right, u is probably x cubed plus 2, but the way you know it for sure, you take the derivative. Do we see the derivative there? Right, the derivative is 3x squared dx, so this is really 1/3 of du is x squared dx. When I do my substitution, x squared dx is 1/3 of du. X cubed plus 2 the whole thing squared is u squared. For the sake of making my life better, I'm going to ignore the limits of integration right now. It's multiple choice. No college board person's going to look at this and care. I just want to know, can I integrate this? 1/3 integral of 1 over u squared du. If you want to think about that as u to the -2 power, that's great. Add 1 to the power, divide by the new power. So this is really -1 over 3u, which is really -1 over x cubed plus 2. Are all the friends okay with the integration piece? Mostly okay? Okay, so the antiderivative is this -1 over x cubed plus 2. What I need to do though is I need to actually evaluate -1 over x cubed plus 2 from 1 to infinity. And if you're really paying attention to my notation, I am not setting this equal to anything. I'm not saying that this integral equals this stuff down here. Why not? Why am I not going to say that this guy over here equals this guy over here? It's an important notation thing. I'm not going to say this guy equals this guy over here because I don't have limits of integration. This is a number. This is a function. Right? And now I'm in, all these things are equal and I'm going to get a function. And now over here my goal is to just evaluate that function, so I'm going to start with a fresh idea. I'm not going to link anything together. And let's get a little sloppy here. -1 over x cubed plus 2 means -1 over infinity cubed plus 2 minus -1 over 1 cubed plus 2. Is that right?
No.
I lost a 3 somewhere, didn't I?
Yeah.
There's a 3 over here. Sorry. And so there's a 3 over here. So there's a 3 there. And there's a 3 there, my apologies. Okay. Everything else should be good. This fraction over here, infinity cubed, plus 2 is infinity, times 3 is infinity, negative 1 over infinity, 0. 1 cubed is 1, plus 2 is 3, 3 times 3 is 9. I think we're going to get positive 1 over 9, which should be B. That is barely a 2-minute question for me. Like this morning when I did this for the first time in a long time, it really took me 2 minutes to think my way through this and get all the way to the end. This would be the kind of question where I'd maybe flag it and say, later. Let me come back to this later when I have a little bit more time. Okay, are all the friends good? All right, so I'm going to give you guys the next 10 minutes, but only 10 minutes, to pick a station. You can go to vectors, you can go to differential equations, you can go to advanced integration, you can go to series, you can go to, what is that, tricky AB questions? Okay. Huh? Series is right over there. You're only going to get 10 minutes before we start the next blitz. So show me what you can do. And Stephen, is the camera set up where I can write on both boards and everyone will see?
Is this the same packet from the first time?
Yeah, they're the same. So everything stays the same in the stations. So when the timer goes off, you guys are going to switch into the blitz mode. So I'll stop what I'm doing up here, and you guys will go. Homework pile. Okay, so I've got homework from Eileen, Giselle, Celeste A2, Almon, Andrew, Carmen, Stephen, Myra, Celeste, David's absent. Oh yeah, no, I know. So for the friends at home, we're going to do another series question. This is in the station rotation packet for series. This is the second series question. And actually, this one's a pretty fast one. A function f has derivatives of all orders. We've talked about this before. This just means can find all derivatives. You can find the second derivative, the third derivative, the fourth derivative. This is something really important that we need for power series, Taylor series, Maclaurin series. P sub n denotes the nth degree Taylor polynomial of f about x equals 0. Because our center is at x equals 0, that means this is really a Maclaurin series. Maybe we're going to worry about that, maybe we're not. It is known, it's very Game of Thrones, it is known f of 0 equals -4. P1 of a half is equal to -3, so that f prime of 0 is 2. Let's see. F of 0 is -4, P1 of a half is -3. We want to show that f prime of 0 is 2. I think the key to unlocking this problem is to zoom in on the fact that we're talking about p sub 1, which means the degree 1 Taylor polynomial for f centered at 0. So p1 of x, if I built it, would say f of 0 plus f prime of 0 times x minus 0. What is that really? That's your tangent line. So p1 of a half is f of 0. They told me f of 0 is -4. F prime of 0, well, I need to show that that's actually equal to 2. So I'm not going to start there. I'm just going to say f prime of 0 times a half. We know p1 of a half is -3. So -3 equals -4 plus a half of f prime of 0. Add 4 to both sides. We're going to get that 1 is a half of f prime of 0, doubling both sides. F prime of 0 is going to be 2. It is important that you don't start off assuming f prime of 0 is equal to 2, but you start with the degree 1 Taylor polynomial, and you know all the things, you just didn't know for sure what f prime of 0 was. That's part A. All right, B. It is known that f double prime of 0 is equal to -2/3, f triple prime of 0 is 1/3, and they want me to find P3. Well, P sub 3 is the degree 3 Taylor polynomial for f centered at 0. If I built it, it would look like f of 0, f prime of 0 times x, f double prime of 0, don't forget to divide by 2 factorial, x squared, f triple prime of 0 over 3 factorial, times x cubed. To build this, put all your pieces together. F of 0, oh, that's -4. F prime of 0, oh, that's 2. So that's 2 times x. F double prime of 0, it's known that it's -2/3. So -2/3 divided by 2 factorial, and no one's holding a gun to my head today, so I'm not going to actually divide by 2 factorial. Sorry about that, Myra, that was a bit graphic. Plus 1/3 over 3 factorial times x cubed. Let's see, degree 3, I ended at a cubic, centered at 0. This is it. That's part B. Part C, timer's going to go off in like 2 minutes. The function h has first derivative given by h prime of x is equal to f of 2x. It is known that h of 0 is equal to 7. Find the third degree Taylor polynomial for h at 0. Now here's where I want to be careful. The first time I did this, I said P3. And that's bad. That's bad. This is the degree 3 Taylor polynomial for f. We don't want P3. We need a new one. The College Board scoring rubric calls it Q3. I don't care what letter you use, but don't use P because P is connected back to F. So this would be degree 3 Taylor polynomial. Taylor poly for h centered at x equals 0. Where you need to be careful though is that h, the derivative of h, is f of 2x. So how would that work? Q3 is going to have the form h of 0, and then h prime of 0 times x, h double prime of 0 over 2 factorial x squared, h triple prime of 0 x cubed over 3 factorial. This is a way to do it. I think you could do it in other ways. Well, how do I get h of 0? Oh, they were kind. They gave it to me. How do I get h prime of 0? I know that h prime of x is f of 2x, so h prime of 0 is f of 0. F of 0 we know from our previous work is -4, so h prime of 0 is -4x. Now I need h double prime. H double prime of x is f prime of 2x times 2. H double prime of 0 is f prime of 0 times 2. F prime, we were told somewhere along the way, is 2, so this has to be 4. So this is 4 over 2 factorial x squared. Finally, we need h triple prime. H triple prime is f double prime of 2x times 2 times 2. H triple prime of 0 is f double prime of 0 times 4. F double prime of 0 is -2/3. So this guy must be -8/3. So this is plus -8/3 over 3 factorial times x cubed. And I think that's it. And I think you guys have about 1 minute left in your stations. So let me double check and make sure I didn't totally blow it. You know, that happens. And that sucks when that happens. Scoring rubric. So let's take a little stroll down memory lane. Let's see, they awarded a point. They awarded a point for the setup. They awarded a point for verifying that was correct. In building P3, that happened over here. They awarded a point if you had the first 2 terms correct. They awarded another point for the 3rd term. Oh, and a 3rd point for the 4th term. We're already up to 5 points. Let's see. Then they say 2 points for applying the fact that h prime is equal to f of 2x. I think they're claiming like all this is the applying. 1 point for getting the constant term. Hurrah, get that. And then 1 point for all the remaining terms, which is this stuff there. In the world of series questions, in my mind, anything that doesn't involve error analysis is a kind question. I'm going to pause filming for a little bit. You guys are going to switch into the blitz mode. So in your practice test, okay, going to change up the expectations just a little bit. I know Lewis is trying to get my attention. I'm ignoring him, completely ignoring him. Okay, between now and the end of the period, you're going to do questions 23 through 28 without your calculator. You're then going to do 76 through 78 with the calculator. It's not, you know what, I'm just going to, let's be a little bit kinder. 76 and 77 with the calculator. You guys have 15 minutes. This is a total of 8 problems. It's a little bit more than I would reasonably expect you to do, but we're going to finish everything else off tomorrow. Enjoy the ride. Palamon, if you need my calculator, it's in the front of my bag. All right. Number 10. So, back it up. So this problem is from the station's rotation for vectors, parametric curves, and polar. This is question number 10. It's calculator inactive. And if all goes well tomorrow, you'll see a different polo shirt. And we'll finish off the second one, which is polar. Lewis appreciates a good polo. All right, here we go. Toy train moves along a straight track set up on a table. Okay. The position x of t of the train at time t seconds is measured in centimeters from the center of the track. At time t equals 1, the train is 6 centimeters to the left of the center, so x of 1 is equal to -6. For 0 less than or equal to t less than or equal to 4, the velocity of the train at time t is given by this expression, where v of t is measured in centimeters per second. Okay, make sure I get this right. I've got a toy train on a straight track. Here's the track. What do we know? The position of the train at time t seconds is measured in centimeters from the center of the track. So if I call this guy here the center, then x of t is going to tell me where I am relative to the center. At time t equals 1, the train is 6 centimeters to the left of center. So right here at time 1, my position is -6. We know that the velocity of the train is 3t squared minus 12, but I only get to use that on the time interval 0 less than or equal to t less than or equal to 4. Don't let me apply that anywhere other than on this interval. Part A, for 0 less than or equal to t less than or equal to 4, same interval, find x of t. X of t. A couple of ways we could do this. You could say that the position is the antiderivative of the velocity with respect to t. So this is the integral of 3t squared minus 12 dt. And so this is t cubed minus 12t plus some constant of integration that I haven't figured out yet. They tell me that the position at time 1 is -6. So if t is equal to 1, x is -6. -6 equals 1 cubed minus 12 times 1 plus c. -6 equals 1 minus 12 plus c. -6 is 11, so I think if everything goes well, c is 5. And you get that your position equation is t cubed minus 12t plus 5. Done. That's a way. Another way is to say that your position at time t, let's use the fundamental theorem of calculus a different way. The position at any time t is the position at the one time that I know plus the integral from my starting point to the final point that I'm interested in of your velocity expression. And I'm going to call this, well, if I'm being sloppy and going too fast, I'm going to say v of t dt. But that's bad because my limit of integration is t. I might be tempted to call this v sub x, v of x dx. But that's bad because we're talking about position. I pick a letter, any other letter, v of p, I don't know, p for like Priscilla or something like that. Sorry, Steve, I didn't mean to distract you like that. So now we've got our position is -6 plus the integral from 1 to t. My velocity in terms of p is 3p squared minus 12 dp. You're going to find the antiderivative. You're going to evaluate from 1 to t. And lo and behold, you're going to get the same answer. All right, B. Find the total distance traveled by the train during the time interval 0 to 4. Well, total distance on the interval 0 to 4. Well, total distance, what do? We would do the integral from 0 to 4 of the absolute value of v of t dt. This is a way to do it. So that means integral from 0 to 4, absolute value, 3t squared minus 12, with respect to t. The problem that we run into here is that we don't actually know, don't know how to find the antiderivative when you have absolute values. And so you get a little bit stuck here. If this was calculator active, we wouldn't be stuck. We type it into the calculator spits out an answer. This is a calculator inactive question, so you need different thinking here. And so here's a way that you can do this. You can say, what do I know? I know that 3t squared minus 12, well, what is that? If I graphed it, it's a parabola. Opening up, vertex down here at negative 12. It looks like that. This has a root. I can figure out that it has a root at 2 comma 0. There's another root over here at negative 2 comma 0. I'm only interested in this part here, the absolute value from 0 to 4. When I take the absolute value, it's going to reflect this part of the graph up above. And so really what I'm looking at is this graph now. This part over here is represented by 3t squared minus 12, no absolute values necessary because I was above the x-axis the whole time. This guy over here is the negative of 3t squared minus 12. It started off life down here, but got reflected, and I can do that with a negative. So I could break up my integral and say integrate from 0 to 2, negative of 3t squared minus 12 with respect to t, plus the integral from 2 to 4 of 3t squared minus 12 with respect to t. Integrate and evaluate based on the caliber of all the people in the room. I'm not actually going to do the integration. The other thing that you could do, and this is not what I was thinking this morning, is we could go back to this idea of total distance traveled. We know what the position function is. We know the position is given by t cubed minus 12t plus 5. So t cubed minus 12t plus 5. I know the position at time 0, or I can figure it out to be 5. The position at time 4 is 4 cubed minus 12 times 4 plus 5. 64 minus 48, 16 plus 5 is 21. Be careful, don't just subtract these. Because what happens is when your velocity is equal to 0, which happens over here at time t equals 2, your particle actually is changing direction. What you could do is find the position of the particle at time 2, which is 2 cubed minus 12 times 2 plus 5, which I think is negative 11. Find how far, what's the distance from 5 to negative 11. This distance here is x of 2 minus x of 0. Take absolute values and you're going to get 16. The distance that you travel between between x equals 2, t equals 2, and t equals 4 is going to be the absolute value of 21 minus negative 11, which is 32. Your total distance is what you get when you add them together, and you're going to get 48.
Did you put 76 and 29?
Oh, bummer. On the answer sheet, did I put? My bad.
Keep on?
Yeah.
Okay.
I have to fix that for next year. If I got it all right, then I'd have to retire. All right. C, a toy bus moving on the same table has position given by x of t and y of t. Uh-oh. Now we're in parametric mode. Because now that bus is not just on the straight track, it can move in the vertical direction as well. Here, x of t is the function found in part A. All right. So x of t is this t cubed minus 12t plus 5. Y of t is this guy here, is the distance from the bus to the train track. In centimeters, Write but do not evaluate an integral expression that gives the total distance traveled during the time interval 0 to 4. So, this is just going to be one of those places you have to know the formula. In parametric mode, the way that we find total distance from t equals a to t equals b is an integral from a to b, square root your derivative of the x position with respect to t squared, added to the derivative of the y position with respect to t squared, all of that dt. So I need to know dx dt. Well, let me slow down a second. We're doing an integral from 0 to 4. I need the derivative of x with respect to t. Well, x of t we had, and I so cleverly erased it. The derivative would be 3t squared minus 12. All that's getting squared. This is x prime of t. What is it really? Derivative of position, velocity. Added to, you have to find the derivative of your y position. That's a constant, that's 0. 12 times the cosine of t over 4 times the derivative in here of a fourth. Don't forget to square. Don't forget the dt. This guy here is y prime of t. In terms of awarding points, what happened with points? Part A, God bless. Part A was worth 3 points. 1 point for setting up the integral, 1 point for finding the antiderivative, 1 point for a final answer. Part B is worth 3 points. 1 point was for identifying t equals 2 as being special. The second point was for considering x of 0, x of 2, and x of 4, meaning you don't even need to, even if you found the wrong number, you've considered all 3 of these, your point where you change direction in your endpoints, and then 1 point for your final answer. In part C, they award 1 point for finding the derivative of y, and then 2 points for your setup. And that's the whole thing.
Let me make sure I did all the questions.
76 and 77 only. All right, I'm going to stop filming at this point.